we're going to consider two scenarios given by Beth and by Pedro, and we're going to figure out whether or not they are thinking probabilistically correctly about what's going on. Beth wrote an explanation for randomly choosing a blue card second and explained why Beth's reasoning is incorrect. It is wrong. It's good reasoning, by the way. She's just forgetting something. Beth says, because the actions are dependent in this problem, the probability of choosing a blue card second is 2/5. No. There are 5 cards left after the first pick, and 2 of the cards left are blue. Stop. The scenario is randomly choosing a blue card second. Think of it as an independent event, and so just consider how many of the cards are blue. Now, she's not choosing a blue card first, so that's out. But there were 3 yellow, purple, and 2 blues. So those 2 blues are available if the scenario is randomly choosing a blue card second out of 6 card choices. 2 of the cards are blue, which means the probability of blue second is 2 out of 6. Let's move on. Pedro says the probability, his scenario. Wrote an explanation for randomly choosing a yellow card first and, that's the key thing, a blue card second. Explain why Pedro's reasoning is incorrect. Pedro says, in this problem, by the way, I'm circling the numbers that I see in a problem. You should do that when you read it. So I'm going to start over and reread again. But notice that I've circled and underlined, and I'm trying to make parts of this text stand out. Here it goes. In this problem, the probability of choosing a yellow card first is 1/2. And the probability of choosing a blue card second is 1/3. So the probability of choosing both a yellow and a blue card is 1/2 times 1/3, which is 1/6. If you scale up 1/6, these are the cards that are yellow first, blue second. 1/6 is 5 out of 30. So 30 things here, only 5 of them should be highlighted, both blue and yellow. But there are, in fact, 6. So Pedro's problem is he should not have used 1/3 to perform the calculation. The events are dependent. So Pedro should look at the yellow collection first. Let me bring that back into play. Don't worry about the rest. Don't worry about over here. That's not yellow first. Look at the yellow card being drawn first. And then, of that group of yellow, calculate a new blue probability, where blue goes second, from just the yellow cards. So of the yellow cards, how many of these cards have blue being the second card? 1, 2, 3, 4, 5, 6. 6 out of 5, 10, 15. The probability of getting a blue card second, given that we're looking at the yellow cards now, as the yellow cards went first, is now 6 out of 15. And 6 out of 15 reduces to is about 3, 2, 15, 3, 5. 2/5. I actually think what's happened here is Pedro and not quite. I don't think Pedro and Beth had switched explanations. But definitely Beth is thinking about the blue given the first card is yellow scenario. So she's looking at just the yellows and then counting the number of blue cards being second out of that group. That's what given really does mean. You have to redefine the total. So this is the total, all of the sample space. But if you start to consider an and probability, then you only look at within that smaller group. That's what Beth was doing. Did Beth calculate probability of B or probability of B given A? No. Neither of them. They're closer to probability of B given A. I guess she used the probability of B given A because she does have a 2/5 fraction in her problem. And that's my point. She had the 2/5 fraction. It comes from this. Readjust the screen. Show how the sample space in question 2 disproves Beth's thinking. If Beth is thinking of choosing a blue card section, blue, 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 blue. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 out of 30 is 1/3. She should have come up with 1/3. Straight up. Beth should have said 1/3, and she didn't. Okay. Thank you for watching, commenting, liking, and subscribing. The next page is the final section of things to consider about dependent or compound probability, or being the addition rule. See you in the next episode.